All right, welcome back. We're going to continue talking about congruent triangles and proving triangles congruent. The last time we talked about using the CPCTC, which was all the parts of a triangle. If all the parts were congruent, then we could say the two triangles are congruent. We also used SSS, or side, side, side. And that was if we proved three sides were congruent, then we could say that the two triangles congruent. Today we're going to explore, I think, four more of those and kind of continue on proving triangles congruent. So we're going to be on page 56 and 57 today. We've got quite a few notes and then quite a few examples as well. So like I said, we're going to start here on page 56. And we're going to title each page the same. So we're going to say here on page 56, there we go, triangles congruent by, and we're going to look at ASA, AAS, SAS, and HL. Okay, so we got four new ones. And on 57, I'll go ahead and write that same title. Triangles congruent by ASA, AAS, SAS, and HL. Okay, the first thing I want to do is kind of go through what each of those mean and how you may use them. Okay, so let's first start off with ASA. So ASA means angle, side, angle. Okay, so that's two angles and a side in between them. So that would say if two angles and an included, that means the side in between them. If two angles and an included side of one triangle is congruent to two angles and an included side of another, then triangles congruent. Okay, kind of ran out of room there. So basically what you want, draw a little picture here. If you have two triangles, there's our two triangles. I have two angles, so this angle, and then this angle and this angle, and the included side, so that's the side in between them. So this side and this side. So that would be angle, side, angle. Okay, it goes in that order. All right, the next one that we're going to look at here is AAS. Okay, so AAS stands for angle, angle, side. So it's very similar to the ASA, but you notice up here, the side is in between the two angles. Here, the side is on the outside of the two angles. So we'd call that the excluded. So if two angles and an excluded side of one triangle is congruent to two angles and an excluded side of another, then triangles are congruent. Okay, so I'll draw another picture here. So you've got two triangles. Okay, you've got two angles. So let's say this angle and this angle correspond, and this angle and this angle. Two angles and the non-included side. So that's the side, just one of the sides not in between them. So let's say this side and this side. If it were the side between them, see the side between the two angles, that would be ASA. But this is the side not between them. Okay, and then we have SAS. So let's look here. We have SAS, which is side, angle, side. So it looks like two sides and the angle between them. Okay, so side, angle, side. If two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then triangles are congruent. Okay, our picture here. So I've got two triangles. Now I've drawn all my triangles not connected, but when you prove them, when you prove triangles, a lot of times they're connected in some way. Okay, so you got side, angle, side. So let's say this side is congruent to this side and this side and this side. So we got two sides and we have the included angle, which would be the angle that connects those two sides. So those two. Okay, so you have the included angle. And the last one here that we have is HL. HL stands for hypotenuse leg. Okay, and this one's a little bit tricky because the only way you can have a hypotenuse and leg is if you have a right triangle. Okay, so here we'll say if the H and L of one right triangle, okay, if the hypotenuse and leg of one right triangle is congruent to H and L in another right triangle, then the triangles are congruent. Okay, so like we said, it has to be a right triangle. So let's say I have this right triangle. and I have this right triangle. Okay, I know that they're a right triangle because of that right angle right there. And a hypotenuse leg, so the hypotenuse here is congruent, and then one of the sides. It doesn't matter which one, they're both legs, so we'll just go with that one. Okay? So hypotenuse leg. It only works with right triangles. Okay, so we have those four. We have these four that we've kind of added here, and these four are on your valid list of reasons sheet right here. Okay, so you are able to use them as well. Okay, so on page 57 now, we're just going to dedicate this page to some proofs. Okay, so or some examples. Let's say I got 1, 2, 3, 4, 5 examples to go on this page. So some will take a lot of room, some will not take very much room at all. So the first thing I want to draw here is kind of what looks like the top side of an umbrella. It's going to be an octagon. Okay, so we got the center here. We kind of got our umbrella. Okay, there's the center. And it wants us to look at two of the triangles. This one and this one. So it might say in the umbrella are the two triangles congruent. Okay, and this is all that they give us. Okay, so when we have this, we can look at some of the angles. Now, if this is a true umbrella, all of these things might be the same size. Okay, but they may not. Okay, so a few things that we can look at here are these two lines here are going to be parallel. So this line and this line, these are parallel. Okay, so that makes these angles, kind of these opposite angles, that makes those the same because those are alternate interior angles. And then these two angles right here are also the same because they're vertical. So all angles are congruent. But just because the angles are congruent doesn't mean that the two triangles are congruent. Again, we don't know anything about the length of any of these, and I would need that. You notice we didn't write AAA up here today, and we didn't have AAA the other day. So these I cannot tell if they are congruent. Okay, they might be. I can't say they're not congruent. Okay, so these may not be congruent because no AAA. There's no angle here. Okay, and a quick little proof of that. Let's say we have this little right triangle. Whoop, that's a square. We got this little right triangle right there. Let's say 90, 45, and 45. Then if I draw this right triangle, 90, 45, and 45, those are not congruent. They are similar, but they are not congruent. Okay, so you may make a note that you cannot use AAA to prove congruent. Okay, you cannot do that. All right, the next example we have says, are the triangles congruent? Okay, and it gives us this picture here. We have this angle is congruent to that one, and this one, and this one. Okay, so that's all they give us. I have this triangle up here, and I have this triangle down here. Now, this side right here, both of the triangles share. Okay, we've talked about this before, that if they share a side, that side has to be congruent, and that was the reflexive property. Okay, whatever that is, if that is like A, B, C, and D, AB is congruent to BA. Okay, they're the same in each triangle. So here I have an angle, a side, and then an angle, side, and angle. So yes, these are congruent. So triangles congruent by angle, side, angle. Okay, an angle, side, angle was one of them that we have talked about. Okay, so that's kind of the idea of the proof. You just need to say that you have these parts congruent, and then the triangles will be congruent. Okay, so I have a actual formal proof. I have two that we're going to look at today. Well, three. And that's what we're going to kind of look at right now. So I have this picture here. I'm trying to draw the picture as accurate as possible here. Okay, B, E, D, and C. It says given CE is perpendicular to BD, and those are segments, and angle CAB is congruent to angle CAD. We want to prove that triangle ABE is congruent to triangle ADE. Okay, so in the proof, we start our statements and reasons. Okay, we'll start with copying this given information down. So CE is perpendicular to BD, and angle CAB is congruent to angle CAD. And that's given. So what I like to do is we'll take this information and put it on our picture. So CE right here is perpendicular to BD. So what that does is that creates a 90-degree angle here. Okay. So what I want to do is I don't have anything over here with a 90-degree angle. So I want to say that. I'm going to say that CEB, so angle CEB and angle CED are 90 degrees. You could also say that they're right angles. Doesn't matter. Right angles. We'll just put both of those. And I know that those are right angles or 90 degrees because those were perpendicular. So that was definition of perpendicular. okay, what we used right there. So now I've got those 90-degree angles there. Then we have angle CAB. Oh, I don't have A on there. A is right here. Angle CAB, this angle, is congruent to CAD, this angle. Okay. Now we kind of have to figure out where to go from here. And keep in mind that you're trying to prove triangle ABE. So let me get another color here. You're trying to prove that this triangle here is congruent to this triangle here. And in order to do that, we need to use one of these or side, side, side. Or you just prove all the parts congruent. Now, I'm probably not going to prove all the parts congruent because that's a super long process. All right. So what I want to look at here is these two angles right here are congruent. Okay, I know that because they're both 90 degrees. So angle, we'll say angle AEB is congruent to angle AED. And that is right angles congruent. Okay, all right angles are congruent. So now I have angle. Okay, now if you see right here, both of these orange triangles share this side. So I can say AE is congruent to AE. They both share that same side, that is reflexive. Okay, so I'll add that that's congruent. I like to put 2 lines on it if it's congruent. And now the next one is kind of a hard reason or a hard statement to make. We need to use this right here. We need to use that these angles are congruent, okay? If you notice here, I have a straight line, or I have a line here, and this angle and this angle add up to 180. They're a linear pair, they're supplementary. And these two angles are also a linear pair and are supplementary. And these two angles are the same. Well, if these two angles up here are the same, then these two down here also have to be the same. Okay, so we're going to say angle BAE is congruent to angle DAE. And this is known as the supplement or congruent supplement angle theorem. Okay, and on your valid list of reasons, you have them right here at the bottom. Congruent supplement angle theorem and congruent complement angle theorem. And it says if two angles are supplementary to the same angle, then they are congruent. Or if two angles are complement to the same angle, then they are congruent. So these two are the same, and they're supplementary here, so they have to be the same. Okay. So now I have that this angle here is congruent to this angle there. So here I have these two angles, these two sides, and these two angles. So this is angle, side, angle. So I can now say that the triangle ABE is congruent to the triangle ADE by angle, side, angle. Angle, side, angle, angle, side, angle right there. Okay, and I had angle, side, angle. That's what I needed to prove was right there. So I am all done with that proof. Again, proofs can be very challenging, okay? But if you know these reasons and you keep in mind where you need to go, they shouldn't be too difficult. And I will post some IXL practice and some other practice home proofs to kind of help you go through some of these. Okay, it's going to be very important though that you are practicing and doing a bunch of them. If you don't do any of them, then it will be very hard on the test for you to know kind of what you're doing. All right, the next proof here gives us this picture. It's kind of a famous picture here, or a well-known picture. Okay, so we've got this is parallel to this, and this, and this. Okay, that's all they give us. And they say prove triangle. So prove triangle ABC congruent to triangle CDA. Okay, so we're going to start our statements and reasons down here. You notice on this one, they didn't have a given part up here. And that's because they gave us information here on this picture. So I still have a given statement and a given reason. Okay, and my given is that this segment and this segment are both parallel and congruent. Okay, so segment BC is parallel to segment AD, and segment BC is congruent to segment DA. Now, here's the thing. I switched it on this part because BC here corresponds with DA up here, okay? Kind of how it's written up there. And all of that is given from my picture. Okay, so looking at this thing, looking at this picture here, you might notice that these two triangles share this side. Okay, and remember when they share a side, AC is congruent to CA. Again, we flipped them, AC, CA. And it's congruent to itself because of reflexive. That reflexive property, kind of looking in the mirror there. So we'll add that to the picture. Okay, so I have a side and a side, side and a side. Now, when they give us parallel lines in a picture, you need to be thinking about the angle types that we had with parallel lines. That is your alternate interior, your alternate exterior, your corresponding, maybe even some vertical stuff. Okay, you need to be looking at that. So these two are parallel, and I have this transversal. Now, this can be hard to see here. So let me try to use some markers and stuff. You have these two parallel lines, and you have this transversal coming through there. Okay, and you are going to have alternate interior angles. But the thing is the alternate interior angles are here and here. They are not these. The alternate interior angles, or even alternate exterior angles, have to connect with the transversal and the parallel lines. These two lines are not parallel, okay? Or they may not be, I don't know. They're not parallel in this picture. So I need to connect the parallel to the transversal here with my alternate interior angles. So now I can say that angle BCA is congruent to angle DAC because of alternate interior angles. Okay, so I've labeled them there. So now I have a side is congruent. That side and this side. Side, an angle, and a side. And notice the angle is in between the two sides. So that would be side, angle, side. Which side, angle, side can prove that triangles are congruent. So triangle ABC is congruent to triangle CDA by angle, side, angle. Sorry, not angle, side angle. Side angle, side. Side angle, side. And I copied just what this was right down here. So that tells me that I am finished. All right, we have one last proof here to do. So we're going to look at this picture. W, X, Y, Z. And we have, I'll write it over here, we have given that W, Y segment is congruent to X, Z segment. We have WZ is perpendicular to ZY. And we have XY is perpendicular to ZY. And you need to prove triangle WYZ is congruent to triangle XZY. Okay, so they give us a picture and they give us the given and the proof, but they don't label anything on the picture, which is totally fine. So statements, reasons, we'll start with our given information. So WY segment congruent to XZ segment. WZ perpendicular to ZY segments. And XY perpendicular to ZY segments. And that's all given. Okay, so now I'm going to take this given information and note it here on my graph. So WY is the same as XZ. Now that's kind of hard because you have this intersection here, so just kind of note it kind of close there, okay? Don't put it in the middle of either one of those segments, and don't double up, like don't put a line here and a line here, because I don't know that that's in the middle. The other thing is WZ is perpendicular to ZY. So you have that perpendicular. So we can name that a right angle. So I'm going to come down here and say angle WZY. And I'm probably going to have another one here. So XY, and ZY are perpendicular. So that's also 90 degrees. And angle XYZ are 90 degrees right angles. And I know that because, again, we've used this before, definition of perpendicular. Okay, now we need to keep in mind that I need to prove that triangle WYZ, so this big triangle congruent to this triangle. Now, this right angle here is part of this whole triangle. So I can say that that is a right triangle. A right triangle has a right angle. So we are going to say that this triangle and this triangle are right triangles. So triangle WYZ and triangle XYZ are right triangles. That is because of the definition of right triangles. Now, because I said that they were right triangles, that opens us to use HL. So I need to prove that the hypotenuse and one of the legs is congruent. So if you look here, I already have the hypotenuse congruent. So I just need to prove one of these sides or one of these sides. Okay, well, in these two big triangles, they both share ZY. So ZY is congruent to YZ. That again is reflexive. Just like with the angles, when we did the angle hopping stuff and proving angles congruent, we used a lot of transitive property. With proving triangles congruent, I'm not going to say every time you're going to use the reflexive property, but if your triangles are touching on a side, then you're going to use the reflexive property. Okay, if they're just touching at a point, you may be using vertical angles or something like that. Okay, so reflexive. So now I have that this side is congruent to this side. So now I have the leg and the hypotenuse are congruent. So now I can say that triangle WYZ is congruent to triangle XZY because of HL. Okay. If you have not said that you have right triangles, you cannot use HL. Okay, like over here, I never said anything about right triangles, so I couldn't have used HL. Up here, I did have right triangles, but in this case, there was no way to prove that the hypotenuse was the same. Or I could prove one of the legs, but there was no way to prove the hypotenuse the same. So that's why I went with angle side angle. Okay, like I said, proofs are very challenging. Okay, the things you need to remember are your valid list of reasons. We're kind of using things here on the back side this time, and just make sure that you're trying. So I will link an IXL kind of practice and another practice so that you can keep trying on doing proofs. Again, you're going to need to practice, practice, practice. They will be on the test, so you need to be well versed in different kinds of proofs. Okay, if you have any questions, feel free to reach out to me. If not, I'll see you in the next lesson.